So welcome back, NCEA Level 1 physicists, continuing on with looking at physical systems through the lens of energy concepts. And today's lesson, we're going to be looking at energy systems. So energy types can essentially be broken down into two different types of categories. In the previous lessons, we were looking at energy forms, which are basically the properties of objects or systems. So we have here a basketball, so the basketball can have kinetic energy at certain points, and it can also have gravitational potential energy. Those are examples of energy forms. But we also have energy transfer processes, and those are the ways that energy can be moved in or out of objects or systems. For example, the work being done by that, or being done on that ball. So we have energy forms like kinetic, gravitational potential energy, elastic potential, thermal and chemical, but we've also got the ways that the energy can be moved from different objects or systems through work, heating, electricity, or waves. So looking at a little bit more detail at the energy transfer processes. So work, which we've already looked at, is how energy is transferred between objects using a force. So remember, force times distance. That is indeed what work is. Heating is how energy is going to be transferred from hot objects to cold objects, which we'll look at in more detail later in the achievement standard. Electricity is how energy transfers from sources like batteries or mains power into the components like bulbs or speakers. And again, we'll look at that in more detail later in the standard. And waves is how energy is transferred in or out of systems through radiation, for example. And again, we'll look at that in more detail later in the standard. Now you'll be noticing that we've discussed objects, but we've also got the idea of a system. And a system basically are the objects that we're actually investigating. So as the example we have here on this slide, if we're looking at the process of how water evaporates from a hot pan, then the system would be the pan itself, including all the water inside that pan, the actual pan, and the heat source that's providing that thermal energy. That will be the entire system that would be investigating. And one of the things we have to do is being able to identify systems. So you've also, when you're looking at a system, have to be able to identify the final and initial states. So when looking at, for example, this toy car going down a ramp, what are the energy changes that are occurring between the final and initial states? So I've given you two options here. Either the cart converts gravitational potential energy to kinetic energy as it rolls down, or potentially at the top of the ramp, the cart has gravitational potential energy, and at the bottom, it has kinetic energy. So just pause the video now, have a little think about that, and then I'll come back and provide the answer to that particular question. Okay, so welcome back. So the correct answer is actually B, because the final and initial states, at least in the concepts of systems, are the snapshots. Okay, at different points of time in the system. Okay, so at the start, you'd have the gravitational potential energy being the maximum, and then at the bottom, at the end of it, the final state would be that the object would have kinetic energy, or system would gain kinetic energy. So you've always got to look, as with the previous slide, what has changed. So in the previous slide, the cart, the toy cart's height had changed, therefore its gravitational potential energy had decreased, and also it began to move. So that also meant that the car had gained kinetic energy. So what about a bouncing bunny? Well, a bouncing bunny, the initial state is the bunny on the ground, the final state is the bunny in the air. So as the bunny bounces from the ground up into the air, he's changed his height. So initially, he's going to have elastic potential energy, or it's kind of muscles in his legs. And then finally, as he bounces up to a height, he's going to gain gravitational potential energy. That's the final state. So when looking at physical systems, you have to basically choose what the system is, identify the initial and final states, and then ask yourself, well, what has changed in the system between the initial and final states? So those are kind of the questions you have to ask yourself when considering energy transformation.